Good morning, dear students. In previous class, we discussed about matrix and its determinant and determinant properties. And today we will discuss about what is adjoint matrix and how to get adjoint matrix from a given matrix. We will learn here. Objectives. On completion of this period, you would be able to find the adjoint of a matrix. So, minor of an element. In previous class, we discussed minor of an element. Suppose 3 by 3 matrix is like A equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. Minor of an element is determinant obtained by deleting the row and column containing the element in the determinant. So, minor of an element is determinant obtained by deleting the row and column containing the element in the determinant. So in 2 by 2 we have only one element after deleting the row and column containing the element. But here 3 by 3 we have 4 elements and we have to find that 4 elements determinant, and that is called the element of a minor. In previous class we discussed. Here once again we are recap. Minor of A11. So we have to delete the row and column where A11 intersects with the row and the column. And then we have remaining 4 elements. That is A22, A2, A32, A33. So we have to find that 4 elements determinant. So data of A22, A23, A32, A33. That equals to, you can say, A22 into A33 minus A23 into A32. So this determinant is called now minor of A11. Example. Let us see one example to get the concept easy. If A equals to matrix 1, 8, 1, 3, 2, 2, 1, 5, 7. Find the minor of 8. So here we have to delete the row and column where 8 intersects. That is first row and second column. After deleting we have the elements 3, 2, 1, 7. And we find the determinant, then we will get the minor of 8. So minor of 8 equals to det of 3217. That is 21 minus 2 equals to 19. Cofactor of an element. A equals to A11, A12, A13. Second row A21, A22, A23. Third row A31, A32, A33. Cofactor of an element equals to minus 1 whole power I plus j into minor of element where I comma j are the row and column number containing the element. Cofactor of A11 equals to minus 1 whole power I plus j, that is minus 1 whole power 1 plus 1 into that of A22, A23, A32, A3, that is equals to capital A11. So you can say cofactor of an element equals to sign into its minor of element. To find the sign, we have one method, or we say formula, that is minus 1 whole power I plus j, where I comma j are the row and column number containing the element. Cofactors are denoted by capital A1, capital A2, etc. Next example, if A equals to 3, 5, 7, 5, 8, 9, 7, 6, 4, then find the cofactor of 7. Solution. Cofactor of 7. Here we have two sevens, we have different places. So here the first we are finding the first row third element position of the 7. So cofactor of 7 equals to minus 1 whole power 1 plus 3 into determinant of 5, 8, 7, 6. That equals to minus 1 whole power 1 plus 3 means positive, because minus 1 whole power 4 is a even number 4. So minus 1 whole power even number means it is a plus 1, or we say positive, into determinant of 5, 8, 7, 6 equals to 30 minus 56. That equals to minus 26. Adjoint of a matrix. Let us see. First we have to understand cofactor matrix. Then we will easily know what is or how to find adjoint of a matrix. Cofactor matrix. It is a matrix obtained by replacing the elements of the matrix with their corresponding cofactors. So you can say cofactor matrix means it is a matrix obtained by replacing the elements of the matrix with their corresponding cofactors. Adjoint of a matrix. The transpose of the cofactor matrix of a matrix A is called the adjoint of the matrix, and it is denoted as adjoint A, or this is ADJ of A, or adjoint A. Completely we can write our short form is ADJ. So adjoint of a matrix means the transpose of the cofactor matrix of a matrix A is called the adjoint of the matrix, and it is denoted as adjoint of A, or adjoint of A. You can write short or complete form. So next example. See here, find the adjoint of the matrix A, that is 1 2 1 3 2 3 1 1 2. Solution: let A equals to matrix 1 2 1 3 2 3 1 1 2. Cofactor matrix of A equals to, here we are replaced the elements with their cofactors. So cofactor means sign into its minor. So you can see here that is we are replaced with the cofactors of its elements, that is 4 minus 3 and minus of 6 minus 3 and 3 minus 2 and minus of 4 minus 1, 2 minus 1, minus of 1 minus 2, 6 minus 2, minus of 3 minus 3, 2 minus 6. That equals to 1 minus 3 1 minus 3 1 1 4 0 minus 4. Adjoint A equals to 1 minus 3 4. Here we are transposed the cofactor matrix. The cofactor matrix 1 minus 3 4 as a column, and now it is here in adjoint A it is as a row, changed as a row. So this is called transpose of a cofactor matrix, and we are saying that matrix is a adjoint matrix. So adjoint A equals to 1 minus 3 4 minus 3 1 0 1 1 minus 4. Next, another example. Find the adjoint of the matrix A equals to 1 2 minus 2 minus 1 3 0 0 minus 2 1. Cofactor matrix of A equals to 3 minus 0 minus of minus 1 minus 0 plus 2 minus 0. That is, I will explain one element cofactor, then like similarly you can write all the elements cofactors. See, first row first element cofactor is, we have to delete the first row first column, and first row first element is positive sign, and its minor is 3 minus of minus 0, that is 3 plus 0 equals to 3. So that is here we are written. And suppose in the first row second element we have here second. To write that cofactor, first we have to write the sign. So first one is positive sign and second one is which is next to the element, that is opposite with the sign of the its neighbor. So one is positive means then its next side element is negative, so minus into where 2 is intersecting row and column, if that is the first row and second column, if we delete remaining 4 elements, determinant is minus 1 minus 0. So here that is we can see. So like this, each element cofactors here we are seeing, that is 3 minus 0, minus of minus 1 minus 0, plus 2 minus 0, and second row minus of 2 minus 4, plus 1 minus 0, minus of minus 2 minus 0, plus 0 plus 6, minus of 0 minus 2, plus 3 plus 2. Next, that equals to 3, 1, 2, 2, 1, 2, 6, 2, 5. Then adjoint A equals to transpose of a cofactor matrix of A. So 3, 1, 2, 2, 1, 2, 6, 2, 5. Whole transpose, that equals to, in the cofactor matrix we have the first row is 3, 1, 2. Now here we have it is as a column in adjoint, that is 3, 1, 2 as a first column, and second column is 2, 1, 2, and third column is 6, 2, 5. So these are our rows in the cofactor matrix, and after transposing we have as a column, and this is called adjoint A. Note, if A is of order 3 by 3, then adjoint of Ka equals to K square into adjoint A, where K is a scalar. If A and B are two non-singular matrices, adjoint A into B equals to adjoint B into adjoint A. Summary. We have discussed about minors of the matrix, cofactors of the matrix, adjoint of the matrix. So, minor of the matrix means in a matrix which element we have to know the minor. For that we have to delete the row and column where that element is located, or where the element is intersected with row and column. After deleting row and columns elements. And the remaining elements determinant is called minor of the element. In 2 by 2, after deleting row and column, just we have only one element, so that is element is called minor. In 3 by 3, after deleting row and column, we have 4 elements like A, B, C, D. So its determinant is AD minus BC. So this is what we learned, we discussed with examples also. And still you have any doubt, you can ask me. Next, cofactors of the matrix. If we understand the minor, then cofactor is very easy, because sign into minor is called cofactor of an element. So here sign is, we can say simply, one shortcut method is in the 3 by 3 or 2 by 2, the first row, first column element is positive sign, and beside which is next to the element contains negative sign. It is a right side or downward side, which is neighbor of the immediate next. That element contains opposite sign of its neighbor. So first one is positive, second one is negative, and again the third element is positive. In the first row 3 by 3 we say plus minus plus. In the second row minus plus minus. In the third row as a first row signs like plus minus plus. Or one method is there, that is minus 1 whole power I plus j. Suppose if we check it is, we say directly first one, first row, first column element is plus. If we check with minus 1 whole power I plus j formula, then also we have positive, that is minus 1 whole power I means row number where the element contains, that is first I equal to 1, so minus 1 whole power 1 plus j also 1, because first column, so column number where the element contains, that is first column, so 1 plus 1 is 2, so minus 1 whole power 2 means plus 1, so plus 1 we can say 1 into something is something, so plus sign, so plus into its minor. Here for first row, first column's element cofactor is plus into its minor, and that is called the cofactor of that element. Like this, every element contains a cofactor. So in the matrix, if we have 9 elements for 3 by 3, so we get 9 cofactors. And adjoint of the matrix. So if we know the cofactors of each element, then we have to put it in the matrix form, and if we transpose the cofactor matrix, transpose of the cofactor matrix is, we can say, adjoint of the matrix. So these are the 3 points, so which is related to each one. If we know the minor, we can understand the cofactor. If we know the cofactor, we can understand the adjoint of the matrix. So these are easy, we can say these are easy steps to know the adjoint of the matrix. So there is a chance to ask any question on this topic, or minor or cofactor or adjoint of the matrix. Next slide, please. if A equals to matrix A, B, C, D, then adjoint A equals to, so in 2 by 2 we can say AD minus BC is the adjoint of sorry, it is a minor. And adjoint means first we have to find the cofactors, then we have to transpose, then that matrix is called adjoint. So here D minus B minus C A, because cofactor of A is D and cofactor of B is minus C, cofactor of C is minus B and cofactor of D is A. So it's a transpose, means D minus B minus C A. So D minus B minus C A. So here option A is correct, but remaining options are, you can observe what they give: D minus C minus B A. So here two options, that is in these two options answer A is correct, that is D minus B minus C A. Now let us see another example. It is a numerical example. That means in the previous one it is a algebraic expression. Now here we have numbers. The example is in a number, so we can easily write if we know the first one. For A, B, C, D, if you know A is 2 and B is 5, C is minus 1, D is 5, then we can, if we remember the previous answer, that is D minus B minus C, like if we substitute A, B, C, D values, then we will get here adjoint A equal to D means 5, D minus B means minus 5, D minus B minus C means minus of minus 1 is 1, D minus B minus C, A means 2. So the adjoint A is, we can say 5 minus 5, 1, 2. So 5 minus 5, here option A is 5 minus 5 minus 1, 2. Option B is 5, 1, minus 5, 2. So D, actually D is 5, minus B is minus 5, D minus B minus C is 1. Actually it is 1, but here in the option A it is minus 1 showing, but it is actually 1. So it is wrongly typed or wrongly printed or wrongly entered the data. Instead of plus 1, it is unfortunately minus 1 came, but actually it is a plus 1. So answer is A. Next, here the question is, if A equals to matrix 1, 2, minus 3, 3, 4, 5, 4, 8, minus 12, find cofactors of first row elements. Here first row elements are 1, 2, minus 3. And cofactor means sign into its minor. So first we will find cofactor of 1, that is plus into its minor, that is 4 into minus 12 minus 8 into 5. 4 into minus 12 is minus 48, and 8 into 5 40. Minus 48 minus 40 is a minus 88. So cofactor of 1 is a minus 88, and now the first row second element is here 2, so you have to find the cofactor of 2, that is the sign is for 2 is minus, into its determinant it's a minus, that is 3 5 4 minus 12, that is 3 into minus 12 minus 36 minus 20, minus 36 minus 20 is a minus 56, and already we have outside minus, so minus into minus 56. And now we have to find in the first row the last element or third element, that is minus 3 cofactor. So plus into its minor, that is 24 minus 16 is 8. So here the option is A, minus 2 minus 9 7, so A is not correct, and B is minus 19 9 minus 1, and it is also not correct. So here showing A is a correct answer, but here it is wrongly entered, because that is not minus 2, that is minus 88, and second one is 56, and third one is 8. So assignment: if A equals to matrix 1 2 3 minus 3 2 1 4 2 1, find the minor of 3. Here 3 is at 2 places, so for each place you can find minor of 3. Next question: if A equals to matrix 3 minus 3 4 2 minus 3 4 0 minus 1 1, find the cofactor of 2. Next question: if A equals to matrix 1 3 2 1 4 3 1 3 4, find the minor and cofactor of 2. Next question: find the adjoint of the matrix A equals to 0 8 2 3 9 5 0 6 6. Next, find the adjoint of the matrix A equals to matrix 1 2 2 2 1 2 2 2 1. Previous exam questions. Find the adjoint of a matrix equal to 0 8 2 3 9 5 6 0 6. Find the adjoint of matrix 1 minus 1 1 3 9 minus 3 6 minus 2 minus 1. Find the adjoint of minus 4 minus 3 minus 3 1 0 1 4 4 3. So here we learned what is minor and what is cofactor and what is adjoint matrix. Let us revision or recall once again. In the matrix, we have easy problems, easy process, easy methods. All are simply based on simple operations, that is plus, minus, multiplication or division. And here we are discussed what is adjoint of a matrix. So first we have to know what is minor, then we know minor of an element. Every element contains a particular value that is called minor. In 2 by 2 and 3 by 3, let us see. And that is one process to find minor of an element. So minor of an element is determinant obtained by deleting the row and column containing the element in the matrix or intersected. So minor of an element is determinant obtained by deleting the row and column containing the element in the determinant. So here A11 minor is, first we have to remove row and column of A11 where A11 is intersect, that is first row, first column. After removing, we have 4 elements, and that 4 elements determinant is called minor of A11. So, next, here we can see next if matrix A equals to 1 8 1 3 2 2 1 5 7, find the minor of 8. First we have to delete the row and column where intersects 8 by row and column, that is first row, second column. After deleting, the remaining elements are 3 2 1 7, and we have to find that 4 elements determinant in the same positions. That means 3 2 has in a first row and 1 7 should be in second row. After deleting, we should not change its places, rows and columns as it is, and we have to find the determinant of that 2 by 2 matrix here. So 3 into 7, like AD minus BC for determinant of 4 elements. ABCD determinant is AD minus BC. Like we can find 21 minus 2, that is 19. You can see here how we are find minor of 8. Cofactor of an element. Cofactor of an element equals to -1 whole power I plus j into minor of element, where I comma j are the row and column number containing the element. Cofactor of A11 equals to -1 whole power 1 plus 1 into its minor. Its minor means A11 minor is, we already know what is minor. So we can write here determinant of A22, A23, A32, A33, and this sign into minor is, we can represent it with capital A11. So that is a cofactor of small a11 element. So elements are indicated in small letters and cofactors are indicated with capital letters. 1 means first row, first column. Its position is showing. Next, cofactors are denoted by capital letter, that is A1, A2, and so on. Example 2. If A equals to 3, 5, 7, 5, 8, 9, 7, 6, 4. Then find the cofactor of 7. So cofactor of 7 equals to -1 whole power 1 plus 3, 5, 8, 7, 6. Determinant of 5, 8, 7, 6. So plus into 30 minus 56, that equals to minus 26. Adjoint of a matrix. First we know cofactor matrix to know adjoint of a matrix. So let us see what is cofactor matrix. It is a matrix obtained by replacing the elements of the matrix with their corresponding cofactors. It is a matrix obtained by replacing the elements of the matrix with their corresponding cofactors. It is a matrix obtained by replacing the elements of the matrix with their corresponding cofactors. Adjoint of a matrix definition is, we can say, the transpose of the cofactor matrix of a matrix A is called the adjoint of the matrix, and it is denoted as ADJ of A, that is adjoint of A or adjoint of A. We can write ADJ in the short form to represent adjoint, or we can write completely adjoint of A. Next, find the adjoint of the matrix A. 1 2 1 3 2 3 1 1 2. So first we have to find each element cofactor. So cofactor matrix of A equals to, here I will explain you first element cofactor. So generally first one has a positive sign and it's minor, positive sign into minor. So first element minor is, after deleting first row first column, that is determinant of 2 3 1 2, and 4 minus 3 is its cofactor. Like this, for each and every element we can write cofactors. And let us see another one, second element of the first row, which is in second column. So that is, we will find now cofactor of 2. First we have to fix the sign, then we will multiply with its minus. So sign is negative because first one is positive, means then its immediate next is negative. So sign into, after deleting row and column, we have 6 minus 3. So minus of 6 minus 3. Like this we will find. So remaining you can see the slides and understand the concept, and then do the homework exercise problems. Thank you.